So in this episode we're going to add, I hope, game controller support to our virtual console. Um, if you recall at the end of the last episode, let me find it, we got the AI working, and we can do interesting things with it. If you've seen my two shorts that I posted, did a decent demo with the Game of Life, which the AI created and then optimized for me, which was fantastic, because it was quite a lot of assembly code. But that was pretty cool. I've made a few changes to the AI assistant actually in terms of how it works, but I'm not going to go through those here. I'm going to produce a little, probably half-hour sort of sideshow episode that walks through that AI code in more detail, while the main series pushes on with developing with Virtual Console. I think both things are really interesting, but possibly interesting to different people. So I will be covering that. I'm hoping this episode is not a gargantuan one. I think it's very straightforward. And towards the end, I may sort of pause and generate a demo using the AI, which we can then use to demonstrate that stuff works. I also want to thank somebody who commented on YouTube. There was a bug in the web worker, sorry, I remember where it was, the web worker, which meant the console was running far too fast. Not far too fast, but it was running faster than it should. The web worker was not stepping on with a cycle count, so it was running a bit strangely, but it's not really impacted any of the stuff we've shown so far. Nothing we've done has been particularly demanding or we've not been cycle counting to get stuff to work, so nothing's really impacted, but it would have been a problem the further we go. So thank you very much for finding that. I'll just post the person's name / link to a comment at the bottom of the video at this point. I don't have it open. Not good planning on my part. I was going to mention who it was. Forgive me. Anyway, we're going to implement the controllers. I have my PS5 controller, which I hope you can see, wired up to my Mac. I was going to use my Xbox controller, but it's my Xbox is currently recovered. I never use it anymore because, well, we've all probably seen the travails of Xbox of late. It doesn't get used anymore. I tend to game on PC these days anyway. I tried to connect the Xbox Elite controller because it was going spare. It turns out that the Xbox Elite 2, Microsoft in their infinite wisdom have butchered the Bluetooth, so you can't use it on a MacBook Pro without lots of hacking around or third-party drivers, which is hilarious given that Microsoft's current Xbox pivot is any device is an Xbox. Their premium controller doesn't work on a MacBook. You couldn't make it up. They have no idea what we are doing over there. It's madness. Well, I think they sort of do, but it's insanely misguided. And what can you say? Well, who am I to challenge the strategy of one of the world's most valuable companies? Anyway, with that out of the way, we're going to implement the controller. I had to have my little rant. I thought it was hilarious. You couldn't make it up. You could not make it up. Any device is an Xbox, except one of the most popular brands on the planet. There you go. Anyway, I made an update to the memory map to support this. It did have controller registers before, but I decided to add some buttons, and I didn't really want anything to start shifting around because it would invalidate some of the code I've all written. So, for example, the VRANK interrupts, the interrupt handlers, etc. So I basically marked the previous 2 bytes as reserved, and we will probably come back and fill them in as we add stuff. I mean, we almost certainly will. And I've moved the controller buttons to the end of the memory map. And if I just search for it, the buttons I added basically. So we had these buttons, and I decided actually I wanted to put a left shoulder and right shoulder button and a start and options button on each controller. I could have squeezed this into a single byte, but it felt more elegant to have it over 2 bytes. And if I decide to add more controls, I can, or we can revisit. So I went for 2 bytes. Yeah, so I changed the spec based on that. I've then written. So let me just find my terminal. I've then written this spec, another spec, control input to MD. This basically has engage brain again. This basically has the spec for the how the gamepad to map over to the controllers. I did ask Claude this morning how gamepads worked on browsers because I've never tried to do this before, and it told me, which was great. And I also came across this rather handy website which you can use to test your controller. So the button mappings I pulled from here by using the controller, and hopefully you can see it tells you what B button and what button they are, and I basically asked it to map the L stick to the D-pad because we're just doing digital 1-0 input, not binary. We could do a range input for that, but consoles of the time didn't have that kind of thing really. I think my BBC had an analog joystick, which I think worked with Elite, but I seem to prefer playing Elite with the keyboard, so make of that what you will. So I basically created a spec that maps that stuff over. Normal kind of start to the spec. I've said I want it to run the sampling to happen at 60 hertz of a renderer, and we'll see how it goes. So I'm just going to copy this. I'm going to open Claude. We will go into the devkit area. Just kind of. It doesn't really matter, does it? Because we're going to be, we're just going to be touching ream devkit. So let's go into source devkit client Claude. But I'll give an absolute path so you can find what it needs. Read the spec and implement the controller handling. I've created a commit as I always do, so we can roll back if we need to. And now let's see what happens. I may do some cutting as per usual if these things take a while. Sometimes I can. I don't think it's particularly interesting on a YouTube video to watch the AI do its thing. And apologies if I seem a little bit spaced out on this video on occasion. I'm no longer ill, but I had a very long week at work. Ended well. However, it was a very long week at work, definitely quite tired today. But I was eager to start doing this because we can do interesting things with the console now, and adding some input, we can start to write basic games, which will be super cool. And I think this episode, I originally said I would take a different path. I think I was going to do something on, do my normal thing where you make edits. My original plan was to let it, I was going to do some more work on graphics, but I thought actually it'd be good to get some interaction going first and then come back to graphics. Perhaps in the next episode. I've also come to the conclusion it would be fun to add a couple more screen modes to the system, basically kind of text modes. The BBC has some text modes. It had its quite famous mode 7, which was the teletext mode, which you may remember if you're in the UK, which was quite interesting, and you could do really crude graphics with it. But what I want to do is, I love kind of rogue type games. It's done, so I'll talk about it in a sec. I love the sort of old rogue type games with the ASCII character graphics. They always tickled me. So I figured we could do a memory layout, which is basically, like 80 characters by, 30 characters or something. I need to figure that out. But 2 bytes per character, 1 byte for the ASCII, another byte for the colour. So it'd be 256 colour, use a full palette, but still not be huge in terms of memory. So I thought that might be fun to look at, because then we could write also that kind of game too, and adventure games if somebody wants to write that kind of thing. So we'll come back to that. It's done. It says it's complete. Let's have a look at where it's changed. Going to a WebStorm. I assume it's changed a fairly limited amount of things, possibly even just. Would it have changed the actual memory map, source console? No, I think it's probably just going to change this. And I think what I'll probably end up asking it to do is to pull out the controller code into its own method, into its own file rather, into its own module. I think that's a little bit hefty now. Okay, a lot of this is rendering. Yeah, okay. Let's just poll gamepad, see what that's called. I assume it's called in the rendering loop. It's only going to be callable once, I should think. Yeah, okay. Shut that down to poll gamepads. Fine. After rendering is completed, it's pulling the gamepads. It's doing our vblank interrupts. It does it before the vblank interrupts. I probably should have said, but it's kind of done. It's done anyway. We want the gamepads, there's some control bits set before we go into a vblank. If we've got a vblank interrupt, so that's good. That's great. Let's have a quick look at the implementation, which is at the top. Okay, up to 2 controllers. It should just be basic mapping into the memory register, so hopefully it'll figure out what is set. Okay, setting the bits for us. Quick look at the spec. Bit 7 is up. Bit 7 is up. Okay, buttons 12 is up. Okay, so basically it looks to have done. I'm not going to forensically go for every line on here because that would be boring, but it looks like it's essentially done the right thing. Let's put a thumbstick dead zone in. We might have to play with that a little bit to get it right. And then at the end it's setting the address, button's address, which hopefully is based on something on the the right. Yeah, that looks right. And this should be 3 on 3. This should be 3. Hang on, no, that's right, because it's, look at memory map. Let's not make this assumption. Memory map. So much stuff. So it's button 1 extended, buttons extended. Okay, so code is button 1, 3 on 1. Yeah, that's right. Buttons extended, 3 on 2 extended. So that looks good. We don't have any way to test it at the moment. That's what we'll do next. Let's just check nothing's broken. Make sure things basically run. We'll do that with our let's do it with our animated smiley. Engage brain James client source. No. Oh, brain. Examples. Assembly. Let's get our animated star field with vblank. Let's see if this works. Because this is quite a lot of stuff, so we would like to think this worked. Okay, let's assemble it. Let's look at the console. Let's run it. Okay, so our star field still works. We haven't broken anything. It's very decent. Yes, it's very decent. Okay, but nothing I can do with it. So let's say how ambitious should we be? We could try and get to do a small test thing, but I wonder if we can get it to control the movement of a square around the screen with the D-pad. Okay, let's give it a go. Create me a new program that draws a small square to begin with, positioned in the center of the screen, and that has a width and height of 8 pixels. In the vblank interrupt, inspect the state of control 1 and allow the position of the square to be modified by the direction buttons. Oof, will we be able to do this? I don't know. I've added a couple more examples. The more examples I give it, the better it is. It turns out, well, unsurprisingly, when we talked about this, the more examples I give it, the better it becomes at being able to put things together. Often it's drawing on examples, picking bits of code out of the examples. But you can see that it's looking at the draw pixel example. A change I made while I watched this do its thing is I was preloading all the examples into the chat. You couldn't see them, but they were all there. And the problem with that is the more examples you get, the more garbage there is for this thing to work through. So instead, I switched it to use a tool. To have two tools that we talked about. One is an example directory, so list out the examples that are available, and then the examples are described. And the other is get an example, so it can look for appropriate examples and code snippets from our library. And oh, blimey heck, that's quite quick. It can look for examples and use those to put things together. You can see here that it's done. It looks at the screen state now. It can capture the screen. I did that. I think that was a tool I added afterwards. It can actually capture the screen, and it can. It's got more effective as a result of all those changes. Basically, I've no idea if this is going to work. I'd be amazed if it does, but I've been amazed more than once in the last few days. So let me press play. It's not working. I'm not surprised. Okay, let's just check we are connected. Still to okay. What I should be able to do actually is if I go into debug, I should be able to hold a button down and go inspect it. So if I now go let's find our memory location. So I held down the down button on the D-pad. So I can go and find our memory map. We're interested in this 0x0136. So I can take that address, pop that in there. At 13031. So I don't think it's actually updating the state. That looks like we've not got any state being updated. Okay. Because that's 0, 1, 2, 3, 4, 5, 6. So here we should see something that is non-zero. The fact it's all 0 means it doesn't mean anything's pressed. Unless the thing I've not thought of up until now is if the rendering loop is I wonder if it's updating memory state in the memory loop, because this wouldn't have been a problem before. Because the CPU's paused, the system's paused, so you couldn't call an interrupt while rendering was going on. But I am wondering if the rendering loop is updating this even when the system's paused, because the render is still ticking away. So let me just see. I'm going to hold a button down. I'm going to keep it held down. I have to run it and pause it. No, nothing's there. So I think it's just not reading the state. Okay, so let's pull out our debugger. Actually, before we do that, let's see if the LM can help us. There's always this choice, and you've seen me make it before. Do I go and debug it manually, or do I debug it through the coding assistant? You could go either way. God, I'm in frightful amounts of indecision this morning. Let's start by asking the LLM. I'm not seeing any change in memory, so I press buttons on the controller. I only have one controller connected. Look at the code and tell me if you see any errors. Let's see what it makes of that. That's like I made a mistake in my spec. It's pulled out, but it shouldn't affect that. We might have to just go and review what it's done on the mapping. If I made a mistake in my spec. Okay. Okay. I don't think. I don't. I mean, it does. It should use the atomics because we're using the shared memory buffer. So that's true. But I don't think it's going to be the cause of the issue. But I think adding the diagnostics is going to be useful. Let's just copy our code. I'm just going to stash this to the side because we don't have to regenerate it. We can just pop it back in. Okay, and let's get the console up. More tools, developer tools. Okay, console, great. What I'll do is just refresh the console. Put that in there again. Let's run that. I need to assemble it, that would help, wouldn't it? Let's reset the console, assemble, run, console, okay. And let's have a look. There's something, oh, that was me earlier running it. So we're seeing that. Interesting, main, press up, main's 80, press down, main's 40, right 10, left 20. So it's setting bits. Okay, let's see what's happening on the console. Okay, let's do a debug. And it's running. I'm going to hold the button. I'm going to do a couple of things. I'm going to get the address out first again. Let's get the address out. And I'm going to, it's running, but I'm going to hold the button down and I'm going to pause it. Ah, so it's setting now. Okay, so it's setting. It looks like it was the atomic. I didn't think that would actually cause an issue, but it did. But we're seeing that set, which is good. Okay, so what we're not seeing is this thing shifting here. So it looks like we've got, let me just, I'm going to hold the left button down, pause it, 20, okay, 20, 20, that's hex. Engage brain, James. I don't have to keep holding that down, do I? I could hold it down all day. Let's get our hexing out because my hexadecimal, my brain is barely working, as you can see. So let's do things the old school. It's gonna be, is it 32 for in base 10? 32. Okay, so is that the right bit? Left. I was holding left down. 1, 2, 4, 8, 16, 32. Bit 6 or bit 5, depending if we count from 0. You have to use all your basic tools and your brain isn't working. Okay. Left, bit 5. Okay, so 0 count, bit 5, the right bit's down. So I think now it's an issue with our program. Let's have a look. Let's go back to our AI. Unfortunately, we've lost the context. What I'm going to do, possibly in a very soon episode, is make the debugger state, the system state, persistent. Because we start to write more complex code and cross boundaries. We need a way of loading things into the system, a cartridge type system. So that will be on an upcoming episode. See the controller flags being set in let's see if it can fix it. I wonder if I've given it the old spec in the examples. That would be wonderful, wouldn't it? Oh dear. Okay, we're going to look at the assembly, what it's using to check these bits. That would be quite funny. If I've loaded the old spec in and it's looking in the wrong bytes, that would be quite funny. I don't think I have. I think it's picking them dynamically, but I might take out that it does say legacy controller, which kind of might imply that you could still read the bits there. So I think I'll take out the legacy controller remark. Again, I love the chatty cheeriness of it. I'm not actually storing to them. Great, thanks. To be fair, when I'm coding by hand, I'm sort of similarly cheerful. If you weren't cheerful in this line of work, it would be a bad thing. Bashing yourself on the head at your own stupidity on a daily basis. I'm going to check what it's reading because I think I've confused it with the specs. So I'm going to have to check the control position. But let's run it, let's see what's happening. Yeah, I think it's reading from the wrong part, so let's find control one. Yeah. Okay, so let's assemble that. There we go. Okay, so issues were mostly to do with our we were missing the atomics call, and that was causing us problems. And then this had a couple of bugs, and it was looking in the wrong memory location, which is undoubtedly due to how I phrased it in the spec. But we can now move a square around the screen, which is, I think, again, pretty cool. And we've got there pretty quickly. From a time point of view, let me see. I need to set my clock running so I don't have to keep popping this down, but we've done that in half an hour. So we've added controller support and generated an assembly program for our fictional CPU inside 30 minutes with the help of AI on both sides. We've used AI to extend our console implementation, and we've used AI to create a basic demo program. What I'm going to do is take this demo program and store it as an example. And I want to add it to the example library. New file. Moving square. Awesome. Controller. Moving square.asm. Okay, let's put that in here. We're going to make sure we update our spec, our memory map spec, so that it doesn't confuse it by talking about legacy controllers. We can put reserved, because that's just going to confuse things. And then we're going to venture into our. I'll probably ask Claude to do this because it can summarize a program and do it. But we will quickly venture into our devkit. And if you recall, our AI runs on the back end. So we've got our API project for the back end in here. Tools, index, here's all the tools. Here's the example list. So I've been adding examples. I haven't put the game of life in yet. But you can see I've been adding these examples, and it's pulling them from the examples directory. So we can in here actually, let's get Claude to do it. I've created an example assembly program. No, I do it slightly different way. Can you add 2 example assembly programs? So go to source, examples, assembly. We'll get that one. Game of Life optimized, which is the faster one, which I seem to have called Game of Lift. Okay, Game of Lift. Okay, well, we could implement a Game of Lift. Optimized, so we've got that path as well. Source AI is tools. Okay. Let's see what it makes of that. Okay, control square. Great, yeah, that's great. Okay. Yeah, so this is the tool I was talking about earlier, which gets and fetches, describes examples and lets the AI get examples. And moving to this kind of system and expanding the examples is really helping the AI generate new code. It's got more stuff to draw on. And it can find appropriate things. I think we end up creating like a snippet of routines that control sprites when we do the sprites and demonstrate how to use all the bits of a system, and you end up with a system that you can either draw on the examples from yourself, as a hand coder, or the AI can draw on. And the better the quality of those examples, the better the whole system will get for everybody, no matter how they engage with it. So it's a really nice kind of like self-reinforcing feedback loop. Which is why we've quickly got to a point where we can get it controlling a square, and why I got it to generate the Game of Life. It's amazing how quickly this stuff kind of self-reinforces. It's really quite something. I'm just going to commit these changes. Our little checkpoint. Added controller support. And the thing I'm going to ask it to do is also, can you move the controller code, not the call, the controller code into a new file, a new module rather, source, devkit client, source, console integration. So we had it in here, here, to a new file at gamepad.ts. The call to it should remain in the rendering loop. Hello, ref. Yeah. Okay, I was distracted by my dog. Oh, you're sleepy. She'll probably settle down here in a minute. She normally does this time of day. Classic retriever. She's got a pheasant plushie in her mouth. I'm wondering if this is one of the small things we ask it to do which seem really obvious and it gets wildly wrong. I hope not. Okay, so we've now got the code moved out. We should still have a bottom of here. That's our fragments. Current texture. Yep, whole gamepads, and that is now over in gamepad.ts. Okay, let's just make sure that works. Refresh this. Control square program. Compile. Run. I think that's the old program. Let me get the new program. Paste in the old program. Yeah, okay, compile. There we go. Okay, so still all works, still all good. I'll probably need to match up the RB and LB. I think I might have confused it in the spec, so I'll just have a look at those things. But I'll probably do that off stream because it's pretty boring, really. Okay. Yeah, so let's try and build this up to a Pong game and see where it starts to kind of break for us. Classic game of Pong. Can we begin by putting a blue coloured paddle on the left of the screen? Let's say, I don't know, 24 pixels high, and think about this, 6 pixels wide. Control 1. Paddle up and down. So I'm going to get a fairly basic brief to begin with, and we'll layer this up. This is how, I mean, I did a bit more by hand, but this is essentially how I did the Starfield animation. Is I slowly layered it up, and that worked really nicely. Okay, so go to console. There's a paddle. Okay. And does it control? Oh, it's not running. Okay, let me run it, see if it controls. Okay, that controls. Okay, I'm just going to adjust the paddle sizes slightly. Make it 4 pixels. Assemble. It's better. Paddle X. Let's move it a bit more to the left. It's too far over. Okay, great, and it clips at the top and bottom. Okay, great, so we've got our basic paddle. I'm going to copy that program because we might well want to come back to it. I could imagine things would go badly wrong. Here's my previous classic Pong game attempts, where I just asked an AI to do loads and it didn't work. I mean, it presented a credible Pong scene, I will say, but it didn't work. So let's add. Next step, let's add the ball. It should start near the player's paddle. That position the paddle. How it's going to do random, I don't know. I think something we need to do is add in like a how long the system's been running counter that it can use to seed random logic. We could even do essentially a sort of hardware thing that each cycle generates a random number, pops it in memory, perhaps 32 bits, so you've got a bunch of stuff to pull from. We'll see. Need to think about that. I think the classic consoles did use essentially cycle counts, time counts. Yeah, I think they did. I can't say I really looked into it. I didn't code on classic consoles. The BBC had from memory, a random function, RND I think it was, in BBC Basic, and I think that went off the system clock because it had a clock, but it might also have mixed in the cycle count since the system was started up. Can't quite remember, but I'm pretty sure the user guide I've got back there would tell me. I've got an advanced user guide that tells me all sorts of things. Wow, okay, we've got a ball that bounces off the top of the screen and it's doing what we would like. That's really nice. Okay, bounces. Okay. And it restarts by the player. Okay, I'm going to copy this code because it looks like it's fairly decent. So again, let's create a new window. Let's keep snapshotting this. And we don't have a kind of cartridge system for storing stuff. Anyway, storing stuff in a devkit yet. We'll need to add that because we're starting to create longer programs now. It's not quite right. Look, when it goes down the bottom, it's coming off the top. Okay. So the bounce off the top is right. We just do a quick test to make sure that is the case. If we were to, yeah, so it doesn't, it just wraps around to the top. Okay. Yeah. Let's see what I wrote. Can't quite remember what I wrote. Need to make that multi-liner. Falls through the bottom. Okay, let's see if we can get to fix that. I mean, it can read assembly a lot quicker than I can. Yeah. I mean, this would, just getting to this point would take it quite a while to do by hand. It would me, that's for sure. And I think even somebody who writes this stuff often still would take a little while to get to this point. This stuff's so fiddly. So fiddly. Interesting, I did get Claude to concede. I mean, I wasn't trying to make it concede something, but I got Claude to concede that LMs writing assembly code is not in their wheelhouse. It said to me that converting pseudocode into this kind of level of detail is something humans are better suited for. I was quite surprised. I asked it basically why it was struggling to do some stuff, and said, what do I need to do to help you more? And part of it was give me better examples, and also this is not something I'm good at, which was really interesting, I thought. That works. So it's fixed it now. Great. Okay. So it's managed to fix it. Okay. Perfect. It's doing well, really. I'm just going to capture this. Okay, so see if it can do this. I think I copied that code. I'm just going to make sure I did copy that code. Okay, got the latest version of the code copied, put to the side. I can't remember actually how Pong bounced. Did it always bounce on this kind of angle? I can't remember. It is a long time ago. I'll have to check, but I'm not too worried. If we just get some basic interaction going with two controllers, I mean, I think that's amazing. Essentially created Pong. There's a paddle. Not sure what it thinks it's doing at the moment, but hopefully it's still coding. That's really funny. I shouldn't find that so funny, but it's quite funny. Sort of paddle juddering away there. I really hope it hasn't actually finished coding. You can see both paddles, but it's not working. Well, let's run it and. When I started this series, I wasn't sure how effective the AI would be, and I had I confess, a somewhat sense of dread about creating particularly the early assembly by hand. So I'm really relieved that the AI is at least not utterly hopeless. It's really saved me a lot of pain. And I'm pretty confident that as we sort of move forward and we start layering up examples, we'll be in a really good place with it, just based on what I'm seeing already. But we'll see. I could be wrong. I could be wrong. Oh wow! I've come back and it's fixed the problems. This is crazy. So we can sort of play Pong now. It's crazy. Okay. I mean, the AI can't lose because of the way the speeds are set, and the way the ball is, the way the ball moves. It's amazing, really. Okay, always resets it there. I mean, I think that's amazing. What can I say? Let's copy the code. Well, I'm just going to remind myself how Pong actually played. I cannot remember. Can we play it on the old 2600? Okay, I'm just reminding myself, see, I don't know if that's the original. Let's, what I'm actually going to do is, I'm going to ask Claude How do the ball physics work in the classic game of Pong? Okay. Interesting. I implemented Arkanoid like that years ago, and I didn't know if it's actually the case, if that's how it worked, but I bet it worked the same in Arkanoid. So that does work. I've copied. Let me just make sure I have copied the code. Okay. I'll make sure I've copied that. Okay. Okay, let's do this in code so I can see. Okay, so if we do that, we should then be able to play Pong. Let's see what happens. Great idea. Okay, so hey, definitely a sometime later moment. However, if you see on my screen, we now have a working Pong game. Didn't actually take that much longer, but I'll take you through what I did to fix it and get the AI to complete the game. Yeah, you'll also notice that the console has got a few new buttons. I ended up working, when I was working on the solutions, I had the browser back in normal zoom mode rather than this zoomed in view I've got for the camera, and so I'm just going to reset this. Yeah, I realised that the console was kind of sitting there in space, so I added some buttons so that you can zoom it, and it defaults to kind of fit to the space available, which just makes things a bit more workable. Well, just much more useful if you're working at a normal zoom level rather than this kind of artificial one. So what were the issues? I'll just start that up again. I think I've still got Pong on the thing. Well, one of the big issues, and the thing that took me a little bit of time to resolve, was the drawing of the numbers, which I don't think we saw when I left off. I should have revisited where we left off. That was one of the issues. And the other issue was it was struggling to detect when things went off the edge of a screen. And I'll talk about those two in that order. The number drawing, essentially what I've got it doing is drawing from a kind of bitmap, literally a bitmap. It's just bits, 8x8 images that are, that show the numbers. Try as I might, the AI just did not seem to interpret my instructions to convert something like that into working code. It would sometimes nearly do it, and I backed and forth a while. And in the end, I decided it was one of those things where I would have to give it an example. So if I look at WebStorm, you will see, if you were to check out the repository anyway, there are more examples now. One of the ones that you would see in here is, let me find it, Draw Space Invader, which was my first go at this. And I took the draw pixel Just dismiss this. Ignore. Fine, just go away. Yeah, so I took the draw pixel that we've already got, that's in the previous example, and I essentially hand coded this assembly in here. And if I go to our console, I'll pop that in here, assemble. Of course, I need to reset the console, that's going to go crazy. Assemble and run, it draws the Space Invader. So I wrote this by hand basically. I wrote from this sort of block of code, here, draw bitmap. I basically wrote by hand. It's not too hard. As per usual assembly, it's just fiddly. I don't profess to be an expert. You can see me messing around with a few things at the top there. So I did that first. My first cut of it, you can see it's just drawing. It just pulls a bitmap directly from the bitmap source. But then I knew at least I could draw a bitmap. I could draw one of these. I then asked it. I sort of evolved that into being able to draw numbers, draw digits. I should say the other thing I did, having written that, I asked it a question about the cycle count. How efficient is it? And we were doing quite a lot of jumps out to draw pixel with stack pushing going on because draw pixel is supposed to work anywhere, and that just added probably about 20% on top of the cycle count. Oh, excuse me, to drawing one of those bitmaps. So it got refactored into this. I use the AI to refactor it into this, where the draw pixel is kind of embedded inside the draw bitmap. Having got draw bitmap optimized, I moved on to draw digits, and I'm just going to copy this in, put it in our console. So now I was like, okay, great. Now I need it to draw more than one bitmap. So I made a few changes. The first change I made this change myself was I updated draw bitmap so that we pass in the low and high flags of a bitmap through registers along with the position and the color of the bitmap. There you go, there's how this works. And having done that, I asked the AI to write me a draw digit that would essentially base it from number 0, win overall 8 bytes long. So given a digit, calculate the offset to the right bitmap, and then call draw bitmap. So I got the AI to do that. And by breaking that down in chunks like that, now if I just assemble and run it, we should see 3 numbers. By breaking it down in chunks like that, I was able to form up an example that seemed useful. And indeed it did. I expanded the example set out in the tools. If we just look at that, I expanded API, isn't it? API. Oh, so much code. I expanded out the examples in here. You can see I put a couple in here, and I've also put the Pong program at the bottom now as well. But I basically added the Space Invader and the draw digits in here, and I took the Pong program as we left it. I pasted that back into the console, and after doing a bit I'll talk about in a second, I've gone back to front a little. I basically said add some score tracking, which it did, and it was able to use the example to then add the score tracking. I asked it to draw the net down the middle, which again it was perfectly able to do. That took no time at all. So all that kind of worked fine. And the bulk of the time I spent off camera was just making that draw digits work. And also I had to do a few live things. I hadn't actually set out the idea of building Pong. I sort of had, but I didn't know how close we'd get, so I might have well bailed. And I had live things to do. So this is actually the next morning when I record this. So the other issue I had was that if I just load up Pong again, let's put Pong back in there. If I put Pong back in there, reset the machine, run the machine. The other issue I had was getting the code to recognise when a ball has gone off the screen, which sounds simple, and it is quite simple. However, because of how it works, so it's looking along. So it's not saying is x greater than 256 or something like that, because that doesn't really quite work. Because over here we are on 256, so there's an overflow potential. It's doing slightly different things. It has to look to see if it's actually slightly over here as well. So it has to look at the direction, and then do the appropriate test. So am I over here, or maybe a little bit over here if I've wrapped round? And the reason you could wrap round is it just depended on the ball speed, the horizontal ball speed, as to how far you would go. And actually what I ended up doing was tuning the ball speed, the overflow check, and putting a directional check in. And it just required me to work the AI through it. It's not saying it was able to do it itself. Well, it did do it itself, but I had to nudge it, lead it through it, saying, I think the issue is that we're on the right of the screen, but actually we're a bit on the left of the screen as well. And actually your check now thinks, because of it, when we check the left paddle and the right paddle, your check thinks it's the left paddle check, the ball was to the left of the paddle. So I just had to sort of nudge it through it. You need to think about the direction that the ball's heading in, and then branch the check in the right way. And I took it through that, and it worked. So the AI actually managed to generate an awful lot of the code. I had to give it another example, and I had to steer it through a fix. It did the sort of typing and the coding, thankfully, but I had to just kind of work it through. So we've got Pong. The scores just go on forever, and we wrap round. Excuse me. Pardon me. We just wrap round. I slowed them. You can see that little bit of judder on the AI. That's me just doing some work to make it not always hit, and I've not quite cleaned it up so it stops moving. It's constantly adjusting still to the ball. So there's lots of tweaks we could do, but fundamentally we managed to get an AI to create Pong for our custom assembler, and our custom hardware and our custom CPU, which is kind of wild. I mean, I still think it's wild. I'll say the other thing I've noticed as well is I'm having to reset the context of the assistant more than I do in the normal development tool, Claude Code, for example. And I think there's a couple of reasons for that. One is I think the assembly all looks very similar, and I think it just starts to get confused by these strange little instructions, which it's never been trained on before, at least our particular variant. But also I think probably the bigger reason is that my tools are quite quickly thrown together, and something like Claude codes have been refined and tested, and a lot of effort's gone into them. There's no way I can replicate the amount of effort that Anthropic have put into Claude code in my little 8-bit system. And I think there's a degree of tool tuning, which I think we talked about when we put the AI system together. These kind of systems, their quality is as much about getting the right data to the AI at the right time as it is about the quality of a model. They both play a big part. And there's a lot we could do to improve that, and we probably will over the next few weeks. I've certainly got in my head this idea that there's a few issues I found in the tools. I think it's capturing the screenshot at the wrong point, for example. So there's just some tweaking of the prompts, the tool descriptions, to try and just tighten the thing up so it works better in context. And as I build out more example programs, inevitably I will tweak the AI. I'll provide it more examples. I'll look at the tool usage, and hopefully we'll get to a place where we've got a really cool system. I mean, I would think it's pretty cool, particularly the amount of time we've spent on it, which is not inordinate. I think this is episode 10, so we could say we've probably spent 20 hours on it. That's probably around there. So maybe a little bit, 20 hours, 10 episodes. Yeah, okay, so most episodes have been about an hour and a bit, 1 2-hour episode. I spent some time off camera. Let's call it 20 hours. 20 hours to create a implementation of virtual CPU, some basic hardware, video memory, code to translate that to the screen, and agentic kind of tooling to develop a coding assistant which is embedded in our devkit. That's not bad for 20 hours work, and some demos. We built some cool demos along the way, culminating in Pong. I think that's pretty good for 20 hours work. Yeah. So that's it for this episode. It feels like a bit of a milestone. We've got our first game, our first game up and running. That's pretty wild. I might have a go at another kind of game, which I'll probably post out as a short, maybe. See where we get to. Thanks for watching, and see you in the next episode.
I found some web results. I can show them if you ask again from your iPhone.
AI.